Okay. Good start. How about 3? How do I know a reflection is about to occur? Yep. What's the notation we used? That's all I'm looking for, lowercase r. Yes? Okay. For a translation, we had the uppercase T, we had vector notation, we had function notation. Well, now we get to rotations. And lowercase r is already taken for reflection. So for a rotation, uppercase print r. That's my notation for a rotation. Rotation notation. Everyone got that? You will also see a subscript. That subscript will be the degree you rotate a figure. So this right here is telling me this is a rotation of 90 degrees, but there's a key piece we're forgetting. Hey, rotate. I could go that way, or I could go that way. Which one is it? When it's positive, it is a counterclockwise rotation. All right? Counterclockwise when you rotate in a positive direction. You will also see a rotation of a negative degree measure. Any thoughts on when that'll be? Clockwise direction. That's a rotation of 90 degrees clockwise. And the third and final one I want you to be familiar with. You will see the uppercase R. You will see the degree measure. But before the degree measure, you may see a letter. A letter. This is still a rotation of 90 in which direction? Still a rotation of 90 degrees counterclockwise, but now it's around a point C that would be given to you. All right, so around point C. If no point is given, like in numbers 1 and 2 here, we assume it's around the origin, 0, 0, if no point is given. Okay? So those are the 3 different rotation notations you could see. Anybody want to comment, question on any of them before we actually get to an actual rotation? All right, so we're going to take triangle DEF, rotate at 90 degrees counterclockwise. Where does it end up? So I'll give you guys a second if you haven't done so already. Go ahead and graph triangle FED. Okay. First, before we actually rotate it, don't try to rotate it on your own. Here's what's happening during a rotation. 90 degrees counterclockwise. So around the origin. So this is what's actually happening. If I connect point, and I don't want you to do this, if I connect point D to the origin, wherever D prime is going to be, I'm going to assume it's somewhere around here. Everyone agree? Because when I go counterclockwise, it's this direction. So I'm going to assume point D is somewhere over here. D prime. When I connect D prime in the origin and the origin in D, it makes a right angle. 90 degrees. This should be 90 degrees that I'm rotating it through. All right, so that's what I'm actually doing, and that's why it says about the origin. So when I connect the pre-image in the origin and the image in the origin, it should form a 90-degree angle with each other. That's what I'm about to do. Okay? How do I do that, though, is the case. You're going to physically rotate yourselves. Physically rotate yourselves. Everyone ready? Everyone got their triangle. Which direction am I going? Counterclockwise. Pretend there's a clock in front of you. Am I going to turn my paper to the left or to the right? Counterclockwise. To the left. And it's 90 degrees, so it's only 1/4 turn. Whoop, to the left. Everyone's got it turned. 1/4 turn to the left. Now do you see you have a new X and a new Y axis? Where is point D, which we're going to call D prime, on that axis. Where is point D now after I turned it? It is at negative 3. And what about its y coordinate? Positive 2. So all I'm going to do is jot it off to the side here, if you can do it. If you can, I know it's a little sideways and backwards, but I'm going to keep my paper just like this, and I'm going to write where these new points are. So E prime, F prime. Thanks, Mike. I like that. Oh, thank you. Thank you. All right, where's your new, thanks. Where's your new E prime? Keep it right there. Don't turn it back. Where's your new E prime? Negative 6, -1. Are we okay here? Okay, what about your new F prime now? -6 and positive 2. Now go back to the original XY axis and graph your new points. And you should see a triangle that's been rotated 90 degrees. Horizontal line. There it is. Rotated 90 degrees. Counter. And again, watch. 90-degree angle you form. If I did that with E and E prime in the origin, 90-degree angle. F prime in the origin, 90-degree angle. Okay. Questions on that one? Going? Whew. Now, some kids have a real trouble rotating their papers. I get it. Okay, I get it. Which way do I turn? How many turns? Okay. Well, first, people always say, well, what if you went anything above 90? Is it always going to be 90? No. What if I went 270? I said a rotation of 270. Everyone ready? 90, where we were. One more, a second quarter turn, where would I be? 180, a third quarter turn, 270. Okay, 270. All right. What if I went rotation of -90? Where would you turn your paper now? To the right? Yep. Which is the same as what? Yeah, if you want to keep that in mind. Okay, if you don't want to turn 3 times, oh, I'm too tired today. Can't do 3 turns. I only do 1 turn to the right. Go right ahead. Yes, Bella. Tomorrow, yes, but not on the graph. Something a little bit different tomorrow. Huh? Questions there? So back to my point. If physically rotating your paper is a physical problem for you, there are rules to remember if you rather memorize rules instead of rotate your paper. So if you rotate 90 degrees, the rule is you take your coordinate, negate the y, and that becomes your x, and your x becomes your new y. If you want to remember that, at least I provided them for you. If you rotate 180, you negate the coordinates. And finally, if you rotate 270, this one's a doozy. You take your y and make it your x, negate your x and make it your y. So if you rather memorize those instead of turning, there they are for you. Okay. Questions? Yes. Well, what did we just say? A rotation of 90 is the same thing as what? A rotation of what in the negative direction? 270. So those rules are the same for -270 and 90. 180 is going to be the same for -180. And 270 is going to be the same for -90. Yep. So it could work clockwise or counterclockwise. Yep.
Can you give us a question where you just give us the points, not the graph? So we have to use those?
No. You'll always have scrap graph paper to do whatever you need to do. Yep, that's always an option. Anything else? Okay, let's actually get away from the graph for a second, and let's rotate some figures. So here's my half triangle. And here's the line L. I'm going to rotate it around. I would want to see if you guys can visualize the three-dimensional object I end up with if I take that half triangle and just literally start one fixed line and we good? All around it. I might have pulled something there. Okay. What three-dimensional object would I end up with? I keep flipping that. It's not a triangle. Keep going around, going around, going around. You're going to eventually see what? What do you got there, Jeff? A cone. Everyone agree? I'm going to see a cone. Yep. So I'll see a cone here, AKA the party hat. All right. First response I got this morning on the next one was a block of cheese. You will not get a block of cheese if you try to rotate that around L. All right. So keep rotating it, rotating it, rotating it, rotating it around. L, what do we think we end up with here now? Keep rotating around, rotating around. What's up, Sammy? It's called a cylinder. Yep. It's a nice cylinder. And how about that circle? Start rotating it around, rotating it around. Will be a sphere. Yep. How do I draw a sphere? Jeez. Start with a circle, a little bend, a little something underneath there. Sphere. All good? So any questions rotating these figures around to make the three-dimensional object? Because this last problem we're going to end it on covers everything we've done so far. Everything we've done so far. Part A, B, C, and D. We're going to reflect, we're going to translate, we're going to rotate. And everyone's going to be involved. What? Yeah, it is. It is a lot of primes. Deal with it. All right. 4 of them, I know. Yep. So go ahead, get triangle ABC graphed. Okay, first one. I need somebody's help for the first one. What am I asked? Which transformation am I asked to do in the first one? Here you go. 13, which transformation am I asked to do? A reflection through. Make sure everyone goes through the X and not the Y. So again, a little review. You count the distance the point is from the X-axis and go that many units in the opposite direction. So I'll give you a second to do that. And I'm going to ask another person, what are your prime coordinates? Hey, how about those new points? 3, how about those new points? 1 for 1. 2 for 2. Way to make your class proud. Next up, what am I asked to do in part B now? 11. What am I going to do? Translate it. Now, here's the key, and Casey already said it, but I need to make a point of this so everyone understands. Guys, you have two graphs up here right now. You have to read it carefully so you know which one you're going to translate. All right? Because, yes, sometimes I may go back to the original, or I may go back to the one you just transformed. But in this case, which one am I translating? A prime, B prime, C prime. So this one I'm going to move, as Casey said, 6 units to the left and down 2. And that'll ask you for your new coordinates then. Ready to give me those new points? New points, double prime points, 14? Yeah. Negative 1.6? Watch your mouth. 0. Okay, come on now, finish. There we go. Whew. Here comes the tough one. Here comes the tough one. What do we ask you to do in part C now? 18. Which transformation is being asked for? A rotation. Which one am I going to rotate? Because I have 3 triangles up here.
The one that we just made.
The double prime one. And in which direction, Belle, am I going to rotate?
Clockwise.
Clockwise, everybody. Hey, clockwise. Clock. So it should be somewhere in this region, not back here. So where are we turning our paper right now? If you are a turn person. Right. To the right. And jotting down those new coordinates. Yes, to the right. Make sure we're in the right direction. Clockwise, clockwise, everybody, like a clock. Jot down your coordinates, turn your paper back to the original graph and plot them. Do we have those new coordinates ready to roll? Hey, 8, how about those new coordinates? Just didn't want to say B triple prime, C triple. Or like first period I had the kids say B prime, prime, prime. Okay. triple prime, as we like to call it. And are you ready for the last one? What am I asked? What is asked in the last one, part D? Here you go, 2. In the last part? What's the R mean? What's translation start with? Okay, and this is N. Oh boy. It's an R. It's a lowercase r. That tells me to well, what are the ones we went over? Very first one we went over. The transformation we first did in class. Reflection. We went through a reflection, we went through a translation, and today we were going through rotation, right? So reflection, lowercase r. Yes? You okay there? That worries me a little. Going into Thursday. You sure? Reflect where? What? Because I have 4 triangles up there. Which one am I reflecting over y equals -2? The original. Hey, everyone. Hopefully you didn't go ahead and miss that. I'm reflecting the original over y equals -2. Before I go, though, what type of line is y equals -2? 19, what type of line is y equals -2? It is a horizontal line. You are correct, sir. Going through -2. Looks like this yeller one right here. There you go. So count the number. Remember, the original triangle ABC is getting flipped over. So count the number of units to -2 and go the same number of units in the opposite direction. The new coordinates. 4. Nice job, Maeve. Nice. -1, 4. Make sure you're doing this one, right? Oh. The original, right? Triangle ABC, the image of triangle ABC. So I got to do the original one. Okay. Take your time. So the x coordinates should not change.
It's 2 and then -5.
Okay. Just hold on right there. Everyone, if anybody got -3, yeah, negative, I wrote it. If anybody got -3 for their y coordinate, that's probably because you started counting from the line. Y equals -2 instead of from the x-axis. So just heads up there. All right, Maeve.
And then it's 6. Oh, -8. Is that not 8?
It is.
Oh, okay. And then 8 -5.
There you go. Ooh. Questions? You will have to graph tonight. All right, so if my graph paper in the back is not good enough for you, I have stacks upon stacks up there on the desk. All right, so if you'd rather use that graph paper, that's fine. All right. Questions? And I'm sure the some of you are probably wondering